Morning. We are gonna totally switch gears now and do volumes completely differently than we have been doing volumes by revolution. Now we're gonna do volumes by cross section. So we're gonna have like a base area, but instead of revolving that two-dimensional area, that becomes just the base of our three-dimensional figure. So let's say we have this function and we're going to bound our area here from, let's say, A to B. And we've got this area then. And now, instead of taking this area and revolving it about the x or y axis, this is just going to become the base of our three-dimensional figure. So the solid's base lies in the xy plane. So it lies in this, and then it's going to come out of the paper. So the cross section is going to be perpendicular to the paper. Perpendicular to the paper. And then finally, the last thing to keep in mind here, we're going to use the space dimension to find the volume of the solid. So we're going to use the base to find the volume. Okay, so we're going to take a cross section right here, let's say right down the middle, and this cross section, I'm gonna draw squares. We're gonna start with square. So we're gonna do a square cross section. So only because that's probably like the easiest one to draw, and I'm not gonna ask you guys to typically draw this, but I'm going to draw it just so you can kind of see what this would look like. So bear with me here. So there's my square kind of coming out of the paper here. I don't have the perspective quite right. I'm going to do another square here so you guys can kind of see what this shape might be, and then this big one, oh my goodness, it's going to almost kind of go off the paper here. There we go. So you can kind of see the squares are getting bigger here, and they're kind of following the same shape here. So hopefully you can kind of imagine that squares coming out of the paper like that. Okay. So there's excuse me. There's a variety of different cross sections we can use. So obviously the first one we're going to talk about is squares. So a square cross section. So this square, I'm going to pick it up and I'm going to place it right here. So placing it down here, and you can see these 2 points here. I'm going to show them here. So if I picked up this cross section, I could key it in right there at these 2 points. And you'll notice if I call this distance D, right, for distance, D, this distance in this case is equal to f of x, right? It's the height, the y value of the function. So if we were to find the area, well, a square means that all sides are equal, right? So the cross-sectional area in this case is just d times d, or d squared. Okay. The next one that's common that you might see is isosceles right triangle. So that one is half a square. So if we took this base, and instead of coming up and doing a whole square, we're just going to come up can do half a square. An isosceles or right triangle, which means isosceles means these two sides are equal, right? And so if this is D, this is also D. So the area here would just be, you got it, D squared divided by 2, right? Or base times height divided by 2, the area of a triangle. Okay, another common one is semicircles. So here we're not revolving into a whole circle, we're just placing a semicircle here, around here, on there. So we've got semicircle placed on that cross section right there. Okay, so that means this distance is D, and we can say, well, it's D for diameter this time, right? So if you remember your geometry, area of a circle, right, is pi r squared, but we're only talking half a circle, right? So we'll divide by 2. And then we want this formula, though, in terms of D, the diameter, instead of r, the radius. So we're going to say r is equal to D divided by 2, and then do a quick substitution, right? So we can substitute that in for r. So that'll be the area is equal to pi d over 2 squared, and then that whole thing is divided by 2. And if we simplify this, this is when you square a fraction, you square the top and the bottom. So this is pi d squared over 4, and dividing by 2 is the same thing as, yeah, you got it, multiplying by 1/2. So you'll see the area is equal to pi d squared over 8 for a semicircle. Can you guys see that? Nope, you guys couldn't see that. There you go. Pi d squared over 8. Sorry about that. Okay, and then the last one that you're going to see, that you might see, is equilateral triangles. So equilateral triangles. And you remember from geometry that equilateral means all the sides are equal. So if this side is D from our picture, right, then this side is D also. And the area of a triangle, area equals 1/2 base times height. That was also from geometry, right? And our base distance is D. This, though, you know, if you remember your special right triangles, this is 60 degrees. So the height here would be the sine of 60, right, times D. So our height is going to equal, well, sine of 60, you guys got that, root 3 over 2, right? Root 3 over 2 times the length of our hypotenuse here, which is D. Okay? So there we have it, when we just substitute everything in. So area equals 1/2, our base distance is D, and our height is root 3 over 2, also times D. So the area, let me see that, yep, area is equal to root 3 over 4 times D squared. And students always ask me, do I need to memorize these? And I just say, if you feel like you couldn't come up with that from drawing a picture, then you do need to memorize them, okay? Or if you just know, oh, I can derive that, no problem, then you don't need to memorize them. So it's up to you. Okay, let's do a quick example. Okay, so here we go. We're going to do a quick example here. Make sure you can see it. Example 1. Okay, let me find the Okay, so our region is bounded by y equals x plus 1, x equals 4, that's a vertical line, and then the x and y axis, y equals 0 and x equals 0, okay? And that region forms the base of a solid with square, we're going to start out with square cross sections. That's my shorthand for cross sections. And they're perpendicular, so perpendicular to the x-axis. So they need to tell you how they're oriented. And just find the volume. So we're going to follow our steps. First step is to sketch that 2D sketch. 2D. So here we go. Sketch y equals x plus 1. Looks something like that. X equals 4. And of course, y equals 0 and x equals 0 are the x and y axis. So we're going to use this base shape and we're going to put squares coming up out of there. So I'm going to draw, that's my D there. Okay, and 2. And then I'm going to sketch my slice like we always do. And this time our slice is a square, not a circle or a washer or a disc. And this is square, so this distance is the same as this distance, and this distance, D, is equal to the height of the function, which is x plus 1. And of course then, because it's the same, that is also equal to x plus 1. And then I'm going to skip our step 3 is bounds. We can write the bounds here, but they've already been given. So we can say x equals 0 and 4, 0 and 4, right? And notice I'm not going to try to draw the three-dimensional figure because it's just too hard, at least for me. Some of you guys could do it. So we're just going to write the integral for the volume. These squares are stacked this way, right? So we're summing our squares from 0 to 4. And the volume of each slice is the cross-sectional area, which is x plus 1 squared, or that d squared for area, times the little tiny thickness of dx. Okay? And the easiest way, I think, to do this one is to just multiply it out. So x squared plus 2x plus 1 dx, and we're going to x cubed over 3 plus x squared plus x, and that's going to be from 0 to 4. And our final step is plugging in. So 4 cubed over 3 plus 4 squared plus 4 is equal to the 124 over 3. Notice there's no pi r squared here because our cross section is a square, so it's just d times d. Okay. All right, that's it. Thanks.